This is a coefficient, and so it's only going to affect the coefficient here. That's why it's 7 square roots of 2. We know that the legs of a right isosceles triangle are congruent, so they are both 7 square roots of 2. But we can't stop there because the actual question was to find the perimeter of this square. So on your diagram, you can go ahead and label that all of these are 7 square roots of 2. And even though we haven't spent a lot of time talking about adding radicals, we have talked about it, I promise, because there was one problem on a workbook page from the blue workbook that we ripped out, that it was, you had a softball field, and we were determining the length that the catcher had to throw when standing 3 feet behind home plate. So they had to throw that 3 feet and then that diagonal of the square infield. And so that value, which I have labeled here x, that value was some radical. I think it was like 50 square roots of 2. Something like that. But anyways, you had to add 3 to 50 square roots of 2. Well, those are unlike terms. They don't have the same base. So we did speak upon adding and subtracting radicals. But you didn't need to know that. And I really didn't pick this problem so that you had to add or subtract radicals. If you look at any any formula chart, if you look at the perimeter for a square, it's not going to say side plus side plus side plus side. They always simplify that and say 4 times 1 side length. So I wasn't hoping that, or wasn't assigning this problem to make you add or subtract radicals, but only to multiply radicals. And so we need 4 of these 7 square roots of 2. So once again, when you multiply radicals, if the number's on the outside, if it's a coefficient, then you multiply those numbers together. Then you multiply the numbers that are underneath the radical symbol, if they're even there. So for this, I started off with 7 of these square roots of 2. Now I need to multiply that by 4. So in the end, I'm still going to have a certain amount of these square roots of 2. It's just going to be 4 times as much as I started off with. And so that would be 28 square root 2. And so that is inches, because that is the unit given to us. We all agree? Awesome. Okay. But, yes, if you added these up, 7 square roots of 2 plus 7 more is 14 square roots of 2, and then 21 square roots of 2, and then 28 square roots of 2. So, yeah, you could have added them up as well, but the formula is 4 times s for a perimeter of the square. All right, the last one. Go ahead and flip to that page in your SpringBoard textbook. This is on page 298. SpringBoard page 298, number 17. It gives us the perimeter of an equilateral triangle. What does equilateral mean, that word? And it can be applied to any polygon. You can have a dodecagon that's equilateral. So what does that term mean, equilateral? All of your sides are congruent. Right? So that is an equilateral triangle. However, with triangles, if it's equilateral, then we also know what about it? It's equal angular as well. That only works for triangles. That only works for triangles. It's the only polygon it works for. So, if that's the case, then what's the measure of each angle of this equilateral triangle? It means each one is 60. Just take 180 divided by 3. Then, it asks us to find the length of an altitude. Find the length of the altitude. Now, we've done a problem like this before. We've done problems like this before, and we know that the altitude is just the height of a triangle. And when your triangle is equilateral, your heights, your three altitudes are the exact same length. Because it doesn't matter which side you use as the base, it's going to have the same height for equilateral triangles. So this is my altitude, or my height of this triangle. It gives us that the perimeter is 36. So by giving us the perimeter of 36, if we do a little bit of work, what else do we know about this triangle? Say it louder. I can't hear anything. The length of all the sides. What do you mean by that? And one side length is? That's all I needed to hear. So, by giving us the perimeter of 36, that means that we can do a little bit of work and figure out that each side length is 12 units long, 12 inches long by dividing by 3. However, we know, and this is what we've done in the past, is that when you draw an altitude from the vertex angle of an isosceles triangle, or from a equilateral triangle, that it bisects this bottom side, so this is 6. So this is just kind of plays right into what we already know about equilateral triangles and these 30, 60, 90 triangles. Because when I focus on this guy right here, this triangle, this is 60 degrees, this is 90 degrees, this has to be 30. So I'm dealing with a 30, 60, 90 triangle. This is the extended ratio that the side lengths will always follow, and what I'm given is actually 2 side lengths. They tell us that the hypotenuse is 12 units long. So even if you forgot that this altitude bisects this side, then you can still use the ratio to figure out that that's 6. Your height is 6 square roots of 3. And then to find the area, which is what I added on, you need to find the area of this. Area of a triangle is base times height divided by 2. My base is what? 12. I'm asking for the area of the only triangle that is being described in the problem. And the only triangle that's being described is the equilateral triangle. Y'all really need to slow down on these problems. And that happened on the midterm that y'all took before spring break. You get so caught up in the problem that you forget what the original question's asking. So please make sure you're answering the question that's being asked. I asked for the perimeter, the area of this triangle that's being described, not half of it. So the base is 12 units long. My height we just figured out using the 30, 60, 90 triangle ratio is 6 square roots of 3, and we're going to take that product and divide by 2. 12 times 6 is 72, divided by 2 is 36. So I have 36 square root of 3. Please make sure you have the correct units. That area is measured in square units. So this is square inches. Any questions about number 17 on the SpringBoard page? This is on page 137, number 16. This is on page 137, number 16. So last night's homework was all about setting up these ratios. Well, now, we're actually going to use these ratios to solve for some side lengths. Use what is printed on the piece of paper. I'm sure that we all can figure out what this angle measurement is using the triangle sum theorem. I think that we all know that it's 26, but if you mess up and you say that this is 36 on one of the quizzes or tests, and then you use that wrong angle measurement to try to find x, you have no hope and no chance of finding the correct answer. So do not do that. Use what is printed on the piece of paper. So, our end goal is to solve for x. I'm going to use what is printed on the paper, angle 64, this angle measurement. So I know that after I choose which trig function I'm going to use, I know I'm going to plug in 64 as my angle measurement, but I need to know if I'm going to use sine, cosine, or tangent. And this is how you determine which trig function you're going to use. You look at what you have, okay? Or what you know. And by that it means you have the opposite side, the adjacent side, or the hypotenuse. So right now, what do we know the side length of? We know the opposite side. We need to use the vernacular that we've been using with these trig functions. Opposite side, adjacent side, and hypotenuse. So we have the opposite side or opposite leg is what we have. What do we need to know, or what are we looking for? I'm going to write N, need, T for to, K for no. What do we need to know? The adjacent leg. We have the opposite leg, 17 units. We need, or we're searching for, the adjacent leg. And this is all with respect to the angle that's printed on the piece of paper. Any questions thus far? You look at the angle that's printed on the piece of paper, and you look at what do I have and what do I need to know. It's always going to be two at a time. Two side lengths at a time. So I have my opposite side. I need to know my adjacent leg. When you figure that out, you then ask yourself, well, which trig function involves opposite leg and adjacent leg? And so you should have written somewhere on your piece of paper the three trig functions. So which one of them uses opposite and adjacent legs? Tangent. That is how you choose which trig function you're going to use. And so in the notation of today's homework that was due, that we just checked, and I projected all the answers, my notation was whatever trig function I asked you to do, or the instructions said, and then in the set of parentheses, I wrote every single time, measurement of angle, then A, B, R, S, whatever the homework was. That's where the angle measurement goes in. That's what that notation is. So tangent, and that was chosen because we looked at what I need to know and what I have. I understand it's written right there, okay? But on the tests and homework, on other homework problems and the quizzes, I'm not going to tell you what trig function you're going to be using. I'm walking you through step by step how to find out which trig, which one of the three you need. You look at what you have, you look at what you need to know. So, opposite leg and adjacent leg, that is tangent. So tangent of my angle measurement equals, and then we're going to write the ratio. Tangent is opposite leg divided by the adjacent leg. So what is my opposite leg's length? And what is my adjacent? It's x. So this is setting up an equation. Tangent of 64 is a constant. Remember, we don't have to use these anymore. I told you about these. Back in the day, you would have had to gone to find 64 on this chart and then look at whatever tangent is and then replace that value. But we don't have to do that anymore because our calculators do it. But we have not touched our calculators yet, and we are not going to touch our calculators yet. Because not all of us have these calculators at home. So just because you don't have these values, just because you don't have these calculators at home, does not mean you can't do the homework. We have yet to use the calculator. Alrighty, I'm going to go ahead and pick up where that video ended. I am looking at workbook page 137, number 16. At the top of each page, I always put my three trig functions. So there's sine, and it compares opposite leg divided by hypotenuse. Then I have my cosine trig function, and that compares adjacent leg divided by hypotenuse. And then you have your last trig function is tangent, and it compares